Welcome to my YouTube channel. So here today we are going to be looking at elastic collision. So what is elastic collision? So let's have a depiction. So let's say we have these two. So when they collide, at that moment you can see that immediately they collide, they might move in opposite direction as long as they do not stick to each other. That is elastic collision. So under elastic collision, what we have is kinetic energy is conserved, or rather it is maintained. That means to say the summation of the kinetic energy that you begin with, we can say kinetic energy initial, we can use O or I, should be equal to whatever summation of the kinetic energy that you are going to end up with. So under this video we are going to be answering problems under elastic collision under 1D. So the example that we might have is, before we look at the examples, the kinetic energy is conserved, and also the momentum. So the symbol for momentum is P, is conserved. So the momentum is conserved. Then they do not stick to each other. So that is elastic collision. So now let's look at some questions. Now before we look at questions, the formulas that we are going to be looking at are, for momentum, we know that momentum, which is P, is equal to the product of the mass and the velocity. So this is the formula for the momentum. So since momentum is conserved, we are going to be saying that the summation of initial momentum is equal to the summation. If you add the initial momentum, it should be equal to the summation of the final momentum, like that. So this gives us, so we know that this will be momentum 1 times the velocity 1 if we have two masses. Initial should be equal to momentum 2, the summation, plus, if we add the two momentums, so this would be the momentum of mass number 1 if we have mass number 1, then the summation of the mass number 2, if we add them, if we have two masses like that, if we add their momentum like that, then that means to say their sum will be equal to the final, we can say M1 final momentum, M1 V1 final plus M2 V2 final, like that. So that is the conservation of momentum. For kinetic energy, for the summation of kinetic energy, we do not use the whole formula, but we are going to deduce. So after coming up with everything, they concluded it by using the relative velocity formula, the summation of kinetic energy. So under this one, this yields what we call by the relative velocity. So relative velocity, we are going to have something like this: V1 initial minus V2 initial should be equal to the same thing. You are going to repeat it by putting a negative open brackets V1 initial, or V1 final, V1 final minus V2 final. It will make sense as we look at questions. So let's now answer a question. Let's say we have this problem. So if we have two billiard balls move towards each other as shown in figure 6.51, the balls have identical mass and the collision between them is perfectly elastic. Then we are told if the initial velocity of the balls are 30 centimeters per second and negative 20 centimeters per second respectively, what is the velocity of each ball after collision? So if two balls have got identical masses, when they collide, they just exchange their speeds. So that's the way it is. So let's say if we have M1 here, we also have, let's say, M2 here, like that. if these are identical mass, this one is moving in this direction 20 centimeters per second. Now it is negative because it is to the left, then to the right it is 30 centimeters per second, like that. So direction is very important. So when two balls have got identical mass, when they collide, when they move like in opposite direction, they just exchange their masses. This one will take the 30, this one will take the 20. That's the way it is. That is a property you should know if they have the same masses. So to find what is the velocity of each ball after the collision, meaning to say after they collide. So a collision is where they strike each other. They can stick together or move in opposite direction. So to answer this question, we know that under perfectly elastic collision, the momentum is conserved. We can say momentum. So we said the summation of the initial momentum is equal to the summation of the final momentum, which will be, if let's say we have two balls, these are M1, so we can be able to say M1 initial plus, if you add the initial momentum of both, M2 initial should be equal to, we are going to have our M1 initial plus our not initial, sorry, since this side we are dealing with the final, M1 final plus our M2 final, like that. So now we are going to replace. Now M1 initial remember we said, what did I write here? Yeah, V1. Very important. I thought I didn't put it there. V1 initial, V2 initial, even here V1 final, V2 final, like that. So with this, now we can be able to replace. So what is our mass number 1? So mass is unknown. Now remember, M1 is equal to M2 since they have got identical mass. Therefore, the formula becomes M V1 initial plus M2, which is just M since they are the same, which you can just denote them with a common letter M. M V2 initial should be equal to M V1 final plus M V2 final, like that. So with this, we are going to divide our M throughout to cancel it. We don't need it like that. We haven't been given the mass, unless if this is the situation, you can do that. So we are going to have V1 initial plus V2 initial should be equal to V1 final plus V2 final, like that. We have the speeds. We are told that the M1 is 30 centimeters per second. So there will be no need for you to convert unless they tell you to express in SI units. So we are going to say V1 is 30 centimeters per second. Then V2 is minus 20. Here there's plus, but V2 is negative 20 centimeters per second. Should be equal to, we have V1 final plus V2 final. So 30 minus 20 will give us a value that is equivalent to 10 centimeters per second, should be equal to V1 final plus V2 final. With this done, we have come up with our equation 1. So now, under our 1D, then we are going to now use, what we are going to say. By relative velocity, we are going to say V1 minus V1 initial minus V2 initial should be equal to the same thing, but put a negative, open brackets, V1 initial minus V1 V2. Why am I doing this? V2 final, like that. V1 initial is 30, if you recall, 30 centimeters per second, minus V2 is negative 20 centimeters per second. Just be careful with the sign. Should be equal to negative this and this. It will be negative V1 initial. This by this, it will be positive V2 final, like that. So we are going to have 30 centimeters per second. Negative by negative, it will be positive 20 centimeters per second, should be equal to negative V1 initial plus V2 initial plus V2 final. So let's increase the font a bit. So 30 plus 20, this will give us 50 centimeters per second, should be equal to too big. So we have the 50 centimeters per second should be equal to our V1. We have negative V1 final, very important, final. So we have V1 final plus V2 final, like that. So this is our equation 2. Then after doing that, you will say solving simultaneously. So solving simultaneously, we are going to have this equation. We are going to take this equation, put it there, also get this equation, put it there, then solve them simultaneously, like that. So if we have two of them, this one is V1, this one is negative V1F. So we are going to have 10 plus 50. This is going to give us, so we are going to add. Why add? Because this one has positive, this one has negative, and they have the same coefficient. So 10 plus 50, it will give us 60 centimeters per second, should be equal to V1 final plus negative. So it's V1 minus V1 final minus V1 final. So this will be 0. So this and this cancels. So we are going to remain with V2 plus V2. It will be 2V2 final. When we divide our 2, we are going to have our V2 will be V2. 60 divided by 2 will be 30 centimeters per second, will be equal to V2 final, like that. So we have found our V2. Now to find V1, just get any of the two equations. You can either take this or this, it will still be the same answer. So let's take this equation. If we take this equation, what we are going to have is, we have our value will be 10 centimeters per second, should be equal to our V1. V1 initial we don't know, or V1 final we don't know, plus our V2, we have found it to be 30 centimeters per second. We take this 30, the other side, it will be 10 centimeters per second minus 30 centimeters per second will be equal to V1 final. 10 minus 30, it will be negative 20 centimeters per second will be equal to V1 final, like that. So as you can see, V1 was 30. V1 was 30 initially. V2 was negative 20. So they have interchanged. So we have found our V1. Our V1 final is equal to negative 20 centimeters per second. Our V2 final is found to be 30 centimeters per second, like that. Then we have, this is what we have. Finally, we have found the 2. Let's look at another question. Let's say we have this one. A 40 grams ball is traveling to the right at 3 meters per second while it collides elastically with a 80 grams ball that is at rest. What is the velocity of each ball after collision? So the velocity of each ball after the collision, so for mass you just have to convert because the momentum has to be in kg there. So we are going to convert these masses. So let's call this one as mass number 1, which is having the 40 grams. Then the one which is having 80 grams. A ball is traveling to the right at 3 meters while it collides elastically with this. So this one is not moving. So let's take this direction to be positive. So it's moving with positive 3 meters per second. So if this one was also moving to this side, whatever, even if it was 5, it could have been negative because this is considered to be positive. This would be negative. So with that said, let's convert this. So how the simple way of converting from gram to kg is just divide 1000. If you are converting from gram to kg, just divide by 1000 grams, then multiply by 1 kg. That's even the changing conversion. So when we do that, we are going to get 40 divided by 1000. This will give us a value that is equivalent to 0.04 kg, should be equal to the mass number 1. Then the mass number 2 will be equal to, you're going to get your 80 grams divided by 1000 grams times 1 kg, which will be your m number 2 will be equal to 0.08 kg. So with that done, we are now going to apply. So we want, what is the velocity of each ball after the collision? We are going to apply the summation of the initial momentum. You can use I or O, should be equal to the summation of the final momentum. So the initial momentum is m1 v1 initial plus m2 v2 initial should be equal to m1 v1 final. In this case, it will be the final velocity for the final momentum plus m2 v2 final, like that. So we are going to have our m1 is 0.04. So we put 0.04 kg times the initial velocity is 3 meters per second plus m2 is 0.08. Remember, it was at rest, so meaning to say its initial velocity is 0 meters per second, should be equal to, let me reduce the font. So this should be equal to mass number 1 is 0.04 times the final velocity, which we don't know, plus the mass number 2 is 0.08 times the final velocity for number 2, which we don't know. So we are going to multiply 0.04 times 3. This is going to give us a value of 0.12 kg meters per second. This times this is plus 0. 0.08 times 0 is 0. So we just forget about that one. So we can say that this should be equal to, we are going to have 0.04 v1 final plus 0.08 v2 final, like that. So we have that equation. Then we are going to say by relative velocity, so it doesn't matter the mass that you have, relative velocity, you are going to have by the relative velocity, you are going to get, where is it? So we have the v1 initial minus v2 initial should be equal to the negative, open brackets, V1 in final minus V2 final, like that. So we have V1 initial minus V2 initial should be equal to the negative of negative by this, it will be negative V1 final. This by this, it will be positive V2 final, like that. Then replace. What is our velocity number 1? Our velocity number 1 is 3 meters per second minus velocity number 2. It was at rest. That one was at rest, if you recall from the question. So we are going to say 0 meters per second should be equal to negative V1 final plus V2 final. So that we have 3 minus 0, it will be 3 meters per second should be equal to negative V1 final plus V2 final, like that. So this is our equation for that one. Then we are going to solve them simultaneously. So we are going to say simultaneously we are going to get our equation. Our first equation that we have come up with is this one. Copy it. Get this one as well. So when we get this one, what are we going to have? So this is what we have. Then, since the coefficients are different, the coefficient that is in front of V1 and V2 are different, it's either you can introduce a number by multiplying, but let's not use that because most of you are not conversant with that. So what we are going to do is, we are going to make V2 the subject of the formula. How? We are going to just take this side, so that we have 3, let's forget about the units, 3 plus our V1 final should be equal to V2 final, so that we can now replace. So when we replace this where V2 is, we are going to say replacing we have a 0.12 without the units. Let's forget about the units for now. Should be equal to 0.04 V1 final plus we have a 0.08, so we are going to say 0.08 times. Now this is V2. Remember, V2 is equal to 3 plus V1 final. So we are going to say 3 plus V1 final, like that. So where there is V2, you put this, that's the meaning. So we are going to have 0.12 should be equal to 0.04 V1 final plus 0.08 by 3. This is going to give us 0.08 times 3. It will give us a 0.24. Then we have plus 0.08 times V1 final. It will be 0.08 V1 final, like that. So this gives us a 0.12, like that. This value goes the other side. It will be minus 0.24 should be equal to, we have 0.04 V1 final plus the 0.08 V1 final. We have just, that has just crossed the other side. 0.12 minus 0.24, it will give us a negative 0.12, which should be equal to, if we add 0.04 plus 0.08, this is going to give us a 0.12 V1 final, like that. So with this value, we are now going to divide our 0.12 divided by 0.12. This is going to give us V1 final should be equal to, we have divided by 0.12. This is going to give us a negative 1, since this is negative. So we have the negative 1 there, meters per second. So we have the negative 1 meters per second. It means to say it is now moving to the left. Remember, this one that was 3 meters per second, it was moving this side, it was positive. So this negative, it means to say it's moving to the left like that. From there, you are just going to get any of the two equations. You can get this equation that you made the subject of the formula, but any of the equation that you have made can still work. So we are going to get this to find for V2. Knowing our V1, we are going to have our 3. Then here there is minus, so we are going to put minus since it's a negative, minus 1. We are going to just put meters per second should be equal to V2 final. 3 minus 1 is as simple as 2 meters per second should be equal to V2 final. So that is how. So V1 will be V1 final. We said it's negative 1 meters per second. V2 final is equal to 2 meters per second, like that. Let's look at our last question. If we have been told find the final velocity of the two balls if the ball with the initial velocity of negative 20 centimeters per second has a mass equal to half that of the mass with the initial velocity of 30 centimeters per second, finds the final velocity. Okay, so let's say we are told that finds the final velocity of the two balls. If let's assume that this is perfect elastic collision. It hasn't been stated, but in the question they should say whether it's perfect elastic. But under this one, we are looking at perfect elastic collision, but in an exam they will specify. So let's assume this is perfect elastic. Find the final velocity of the two balls if the ball with the initial velocity of negative 20 meters has a mass equal to half the mass of the ball with the 30 centimeter, that of the ball with the initial velocity of 30 centimeters per second. So what are we going to have? We are told that the mass number 1 has got half the amount of mass with the ball that is traveling at 30 centimeters per second. So mass number 1 is equal to half the mass of number 2. That's the meaning. So if you analyze it really well, that is the meaning. So mass number 2 is the one that is moving at 30, so it will be half. Mass number 1 is half this mass. So this means to say what you can do is you can even cross multiply 2 times m1. It will be 2m1 should be equal to m2 to make it easier for you. So this is what we have. So m number 2 is equal to 2m1, like that. So using the same approach, we are going to say momentum is conserved. Therefore, the initial momentum is equal to the summation of the final momentum. So the initial momentum will be equal to mass 1 times velocity number 1 initial plus the mass number 2 velocity number 2 initial should be equal to the mass number 1 velocity number 1 final plus mass number 2 velocity number 2 final. So that we have, what is our m1? So our m1, let's call these units as so our m1, we are just going to say m1, then the velocity it's moving at is a negative 20 meters per second. Okay, before that, let's just replace for m1 and m2. So we have m1 v1 initial plus m2. We said that m2, after making m2 the subject of the formula, so where you see m2, put 2m1. That's the meaning. So we are going to put, where there is m2, we are going to say 2m1, so that we can have like terms. V2 initial should be equal to M1 V1 final plus, where there is M2 you put 2 M1 V2 final. If someone decided and put where there is M1 they put half M2, it will still be correct. It will still produce the same answer, but taking this one is much easier. So since M1 is the same throughout, we can divide it, we can divide it, we can divide it, we can divide it, so that we have a value that is equivalent to, we have our V1 initial plus 2 V2 initial should be equal to V1 final plus our V2 final, like that. So this is what we have as our equation. So we can be able to replace now velocity number 1, the one number 1, it is negative 20. So we are going to put our negative 20 centimeters per second plus 2. This one is moving at 30 centimeters per second according to what we have been told, should be equal to V1 final plus V2 final, like that. So that we have negative 20 centimeters per second, 2 by 30, it will be 60 centimeters per second, which should be equal to V1 final plus V2 final, like that. So negative 20 plus 60, this will give us a value that is equivalent to 40 centimeters per second, should be equal to V1 final plus V2 final, like that. If that's the case, we are now going to go to relative by relative velocity. So the relative velocity gives V1 initial minus V2 initial should be equal to the negative of the same thing, V1 final, but it just changes to final, minus V2 final, like that. So that we have V1 is negative 20 centimeters per second minus V1, remember, let's move this a bit, minus our V2, which is equal to the 30 centimeters per second, but this negative is from the formula, should be equal to negative V1 final is unknown, so we can just open the brackets. Negative by positive, it will be negative V1 final. Negative by negative, it will be positive V2 final, like that. So negative 20 minus 30 is negative 50 centimeters per second, should be equal to negative V1 final plus V2 final. So we can call this as our equation 1, this one as our equation 2. So with this done, we are going now to solve them simultaneously. So simultaneously, we are going to take this equation 40, saying 40 is equal to V1 final plus V2 final. Then this one is saying negative 50, like that, should be equal to negative of V1 final, this equation, plus V2 final, so that 40 minus, so if you see they have the same value, they have the same coefficient, which is 1, and so we can subtract them. So V1 minus V1, so we are just going to add everything since these have got the same value but different signs. So 40 minus 50, so we are adding, but if it's negative it will be 40 plus positive times negative, it's negative. So we are just going to say 40 minus 50, it will be equal to negative 10, should be equal to V1 plus negative, this and this will cancel, V2 plus V2, it will be 2 V2 final. Then is this what we had? No, we had this equation. Where is it? Okay, yeah. So we forgot this 2. So this 2, we forgot it. So it's supposed to be 2 there, 2 there, 2 here. Yeah, so the final will be 2 there. So even here, it will be a 2. We shouldn't forget that. So we have a 2. So when we have 2 plus 1, the coefficient here is 1. 2 plus 1 is 3. So we are going to have a positive 3 like that. Then we divide our 3. It will be equal to V2 final. So 10 divided by 3, it will be negative 3.3 meters per second. Should be equal to V2 final like that. So that is our value, negative 3.3 meters per second. Negative meaning to say it is moving in to the left like that. Then take any of the two equations, whichever you want. If you want, you can take this equation or this equation. Let's take this equation, which is saying 40 should be equal to, we have V1 final plus our 2 V2 final. Let me just confirm if, okay, it's okay. So 40, okay. Yeah, so this is the equation. So we are going to say 40 should be equal to, V2 is the one we know, it's negative 3.3. So we are going to say V1 final plus 2 by 3.3. That's the value of V2. Is it minus? It's negative. So we are going to have V1, 2 by negative, it will be negative 6.6 like that. Then here we have 40. V1 final. So this one goes the other side, it will be 40 plus 6.6. It's in centimeters per second. Don't forget the units. V1 final, unless if you are told that they want the SI units, that's when you can convert for that one. 46.6 if we add. So this is the speed of V2. What units have I put here? It's in centimeters. So they gave us the units to be in 20 centimeters per second. So that is what we are going to have there. So our V1 final is equal to 46.6. Our V2 final is equal to negative 3.3 centimeters per second. So there's a second there. So that is how we deal with those questions. Thank you very much for watching. Hope you would like, subscribe, and share for more. Don't forget to subscribe so that you do not miss any of this content. See you in the next tutorial.